Hi everyone, my name is Lydia and this is what I wish they had taught me about econometrics and introduction. In today's video, we will talk about mechanical and statistical properties, how are they different and why it's so important to know the difference between the two, and especially how do assumptions fit in this entire picture. Now, keep in mind, mechanical properties come directly from algebra. So that means that they are true for any kind of data that you will be looking at. So, always true. And the reason for that is because they stem from the minimization problem of the OLS. Which, if you remember, is the minimization of the sum of the residual square. Because they will come directly from algebraic manipulations of the first order conditions, that means that they are basically said to always be true. And again, they will be true for any kind of data. So no matter of the data, okay? What about statistical properties then? Well, statistical properties are not always true. In fact, they can only be true only if certain assumptions are fulfilled. So what does that mean for us? Well, that means that the statistical properties actually require you for the world or for the data generating process to behave a certain way. So data generating process or the real world needs to behave a certain way. In fact, now we have kind of already talked about some sort of assumption, some sort of condition for these statistical properties to be fulfilled, which means that the only way assumptions will fit into this big picture of mechanical versus statistical properties debate, it's through the statistical properties. These are indeed those assumptions, those conditions that we just said that make the statistical properties true. You can think of the assumptions, in fact, in a way as the process. That translates the mechanics of OLS. And keep in mind, when I say mechanics here, I'm not talking about the mechanical properties of the OLS, but I'm talking about how OLS works in general, into meaningful statistical guarantees. Okay? So what does it mean in simpler words? Let's think about, again, about our Batman metaphor. So what it means is mechanical properties are the engineering. You know that the Batmobile, all it does, it drives, and you know it does that. Statistical properties would be the road conditions. It means the Batmobile drives accurately only if Gotham is behaving, meaning the roads of Gotham are not changing like the maze that changes its way in Harry Potter. The most important thing is now making a summary of like, well, why is this important? We have touched upon this in another video in this playlist. However, we didn't explicitly mention these are the principles and the concepts on which we are basing that on. So if you remember, we've had a debate between two different statements. X is orthogonal to residuals, and the other one is X is uncorrelated with the true error term. Now that we know the distinction between mechanical and statistical properties, well, the first one is always true. That's a mechanical property. The second one, well, not always true. We need certain assumptions about this. So this is a statistical property. Note something that will make your life a lot easier to distinguish whether a statement is talking about a mechanical property or a statistical property. When we talk about mechanical properties, we're always going to be implying the residual. Because remember, the residuals are something that can be calculated, and the residuals were at the base of the minimization problem, which means they are more likely to appear in the actual proofs or algebraic manipulations that appear in the mechanical properties. The error term was something that we do not observe directly and we can't quantify, which means we have to do certain assumptions to understand how this error term is behaving. And that's why anytime you are talking about statistical properties, you are talking about some sort of condition on error terms and not residuals. Okay? So in order to summarize this entire video before we move forward, remember, the mechanical properties always hold, but the statistical properties depend on the assumptions that are appropriate for your specific data setting. I hope this was helpful, and I'll see you in the next videos where we talk more in detail about both mechanical and statistical properties.